This is the fifth in a series of video-based lessons that is a direct continuation of our Introduction to Relational Data Model, or RDM, as the foundation of modern database systems. We begin by wrapping up our discussion of RDM integrity rules by examining the effects of update and delete operations on affected tables, we just glossed over at the end of the previous recording. We then continue the study of RDM with detailed discussion of relational operators, since they provide a foundation for querying existing databases with SQL. This material is covered in the second part of Chapter 3 in the textbook. We've seen how Microsoft Access database visually represents the relationships between sporting goods tables. Most of those relationships are one-to-many, 1-M or 1-infinity symbol you see on a slide, connecting customer parent table in which a single row corresponds to many rows in the child orders table. We will discuss different types of relationships, such as many-to-many, between orders and products in much more detail in the second part of the class. For now, you just need to be aware of this concept so you can understand what to expect from querying multiple tables in a relational database. The remaining database integrity issue for us to discuss is that of cascading delete and update operations. The issue is best described in an example. What should be done with customer orders in order table if a customer row in customer table is either deleted or the primary key updated, which should not happen if the primary key was carefully selected. Several different actions are possible described on this slide, with cascading delete and update being the most common. With this choice, the same action is performed to the related rows. So, if a customer is deleted from the customer table, all the orders are automatically deleted from the orders table. In the absence of cascade rule, the restrict action is the most likely, since it will not permit the customer row deletion in the customer table without deleting related rows in the orders table first. The same holds with the insert action. We have to insert a customer row into customer table first before we can insert related orders into orders table, which only makes sense. The reminder of this video recording provides an introduction to the elements of relational algebra, describing the use of relational operators in transforming one or more tables into a new temporary table. The knowledge and understanding of relational operators provides a foundation for SQL query formulation, aka query design. The most widely used and arguably the most important relational operator is the select operator that retrieves a subset of rows from a table, such as all the customer for the state of Minnesota, shown at the bottom of the slide. Select operator is typically used in the conjunction with the project operator, which simply means that the number of columns is restricted to the specified subset or list, such as the one showing customer gender and type at the bottom of this slide. The resulting table can often contain a number of duplicate rows in this case, and then a distinct statement is then used to get the unique combinations. Product operator creates a table with all possible combinations of rows from the two tables. With a 2-row salesperson and 3-row item table shown on the left side of the slide, we have the item product salesperson or item times salesperson table with 3 times 2 equals 6 rows. Most of the database tables have many more rows, so the resulting product tables are often huge, and most of the combinations are meaningless. We use it primarily to explain the inner workings of relational operators rather than advocating its use in practice. Join is an operator that builds a new table by combining rows with a match on a single column, such as person ID in this example. This type of join is called a natural or equi-join because the values have to match exactly and is used the most often. The two variations of a natural join are discussed next. Sometimes we want to show the non-matching rows because they give us additional information. For example, using a full outer join on the salesperson and quote tables includes the non-matching person ID of 33 and null. The inclusion of person ID 33 in the resulting table, right here, shows that Sam has no quotes of potentially valuable information, including the null value in the person ID right here. Foreign key from the quote table shows that quote 444 right here has possibly been auto-generated online. If you want to preserve the non-matching rows from one side only, example from the quote table side, you specify a one-sided outer join shown on this slide. Next, we're going to switch quickly or briefly to the hands-on part of this recording by opening the ACC DB2 Sports Access database. So let's switch to the 02 Relate DM folders lectures subfolder, the one we've been using all along, and open up the Access ACC DB2 Sports database, and then click on Database Tools and Relationships, and then double click on the connector or the line connecting customers and orders tables. Okay, the Edit Relationships window will show you a couple of things. First, it shows you customer ID is the common field between the two tables, customer and orders. And the enforcement of referential integrity is checked. The cascade update and delete is not checked, and by checking those two, you will enforce those integrity rules that were discussed at the beginning of this recording. For now, we're just exploring these concepts, so you shouldn't have to do anything. Next, click on Join Type button to review the three possible join types. The default, as we just discussed, is the natural join, where the rows in the combined table are included only if the join field customer ID from both tables are equal. Clicking on the second button would create an one-sided outer join with all the records for customer table, including the resultant tables, but only those rows from orders table where there is a match. This would be equivalent to including Sam, a person with ID 33, but not the quote 444 from a couple of slides ago. In the customer order relationship, if there are customers without orders, they would be included in this one-sided outer join, but not in the natural join. Since the customers without orders are considered prospects and are not included in the customer table, this would not have any effect. The third option right here would create a one-sided join where all the rows in orders table would be included, but only those in customer table for which there is a match. Again, since there is no order without a matching customer, this would have no effect. In our salesperson quote example, this join would include quote 444, but not salesperson 33. So close or cancel the relationship window, closing the relationship window altogether, and then exiting from Access, returning back to the presentation. The next two slides describe the three operators that are not used as often. For all three, the pairs of joining tables would have to be compatible with the same number of columns and data types, which is rarely the case. However, if properly prepped, the acquired customer table could be merged with the existing customer table to show all combined customers, that's a union, the common customers intersect, and the customers that were just ours prior to the merger, that's the difference operator. We will use some of these operators when working with SQL queries, such as the one combining customer and salespeople tables on the compatible fields listed. The union could be used in analyzing salespeople territory assignments and look for other patterns. Also, please note that Microsoft Access supports only union operator. The summary operators, such as count, sum, and average, on the other hand, are used quite often. The resulting summary tables, with columns representing different summary functions and rows showing the aggregate results by different groups, will be discussed more in the next video. And before we move to the import, let's take a quick break.